I can't stay after 4 Tuesday. What? Can't stay after 4 Tuesday. But I have meetings my plan. Oh, really? What time does this start? 3:15. Oh, really? Started at 3. I thought it started at 3:30. I'm not home. That's fine. Okay, smart physics. Magnetism is hard. All good. I was really scared because it showed pre-lecture like 33% done, but it's just because I hadn't refreshed in a while. Okay, emotional EMF, Ampere's law. Yes, can we do this one? Can I draw on the board? Sure.
Someone comes with groups together instead of one person. Or two people, two words. Okay.
Okay, so hey. P zero.
Which one are you doing?
Ampere's law, magnetic field from currents and a wire, and a cylindrical shell.
That's the lecture we got today.
No. Plus.
That was a week ago.
What?
That was a week ago. Ampere's law was a week ago.
Oh,
Yeah.
Friday's lecture.
What? Friday is what we get today.
Mm-hmm.
Can I work on that or no?
Sure. Do you want to work on the board, or do you want to do it together? I'll just go ahead.
Quite sound.
Friday's one. Did you do the ones emotionally, Emma?
What?
Did you do the ones emotionally, Emma?
What are we talking
The ones for yesterday.
about? The lecture that was due yesterday?
Yeah. Not the lecture, the homework that was due yesterday.
Oh, I finished that.
Okay, good.
How come Paradise Law homework is due? Is that on the midterm?
Yeah.
How come it's due after the midterm?
Oh, yeah, no, it's due. Oh, yeah.
The
It's
30th.
due. Yeah, because the homework's always due Monday.
That's weird.
Yeah,
When's our
because
exam?
next Tuesday.
Next Tuesday?
What?
Isn't it next Thursday?
I think it's next Tuesday. I think so. Because this Thursday is going to be a review session. Next Tuesday should be the exam.
Physics 2 exam is not this Thursday.
What?
Physics 2 exam is not this Thursday.
It's next Tuesday.
Wait, you thought it was this Thursday?
I
Like
did.
this one?
Yeah.
I knew it wasn't because I was not ready.
Yeah, it usually gives a one class period for review.
So that homework isn't due after the.
Oh, it's due when?
Friday's going to be
Next Sunday.
Yeah.
Okay.
I was so concerned about that. That is so great.
What are you talking about? This homework is due already.
Yeah, I know. Just had a question. Okay. Okay. How do I do this? I'm supposed to do it. Along the dot is it?
What's the entire integration of the enclosed surface?
Right. There is no enclosed.
What do you want to work on?
Fridays.
Fridays. Did you look at them?
Yeah, but I didn't start looking at the homework.
Okay. How many are they? Because I have to leave at 3:15 today. I can't.
What time did it start?
3
It
to
starts at 3:15.
And you have to leave at what
At
time?
4:15, so I can't stay overtime today.
Yeah. I just want to, whatever time you're here for, I just want to spend this.
Okay.
Is there anything on the board or here?
Oh, we did this today.
Yeah, we did this today.
Okay.
Were you in class today?
So I know how to do that.
What's the integration of P.TL over closed surface? This should be 25. If this was here, then it's not an integration.
Can I leave computer?
Wow, that's hard to read. That.
Yeah, that's a total one though. If you had this surface here, that's what.
Oh, right, that's what that. Okay, so,
Get to it. Don't pay attention to what he's saying. He's already did it.
1/8. That didn't work.
Shit. 1/8 equals 1/8 line equals.
I did this, it didn't work. I looked it up. They told me do pi over 4 times d. And, this. That's okay.
B at a distance. This is B bar.
Are you showing me that they're raised?
This is 2 pi r. Which is that t, which is the entire path. Over 8, this quantity.
Don't have an R.
R, B of R. This is B of R. This is R. So no, actually B of R. So,
Yeah. I just don't understand why smart physics is like, no, you're not right. And then you do that. I multiplied by 1/8. How is that easier? Or harder?
try it again. Show me the sheet.
I don't have mathematics on so. Oh wait, it doesn't work anyways. Wait. What did you do? I may have lied. Wait a second. What?
Of course it's going to work.
What is the angular frequency? Is that where you have
Change of theta over change of time. Theta to t. Angular frequency. No, sorry. That's only got 2 pi r.
there's p is equal to
Angular frequency.
so you
Angular frequency or angular?
angular frequency. The formula.
Omega, okay, radians per second. Yeah, that's theta pi to theta dt.
What?
That's what?
That's not 2 pi? Oh my goodness. 2 pi.
2 pi, okay, but you
That's
have
the-
frequency. So yeah, it's just d theta dt, the change in radians of the change of seconds. What do they give you? Conducting current, blah, 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 resistance, blah, rotation, blah, blah, blah. And you can apply the error, blah, blah, blah.
Makes a complete rotation in time. Makes a complete. Oh, I don't understand how this thing is. Like, is it up or is it flat down to the line?
Right now it's like this. Y is on the triangle on the H. Y-axis is on the H. So conducting wire is going to shape it, blah, blah, blah.
So you
Base.
make the 180 rotation, or you want to say complete rotation?
No, I believe 360 complete rotation. Did they say complete rotation? Conducting wire,
Okay.
Triangle makes one complete rotation time t equals, oh yeah, one complete rotation time t equals 1.2. So it
It
goes,
makes it 2 pi.
it's 2 pi. to pi f because they give you basically time period.
I found what I guess I did this times 1/8. Do you have a sign-in sheet anymore? Or?
Yeah, I do.
What do we use? A number and name? No email?
You don't want any materials in the email.
Is this? Those are cups.
Okay, how do you find them? The I max is negative this rate. Yeah, and the
Negative is just a direction. So you really shouldn't include the negative sign.
no.
Yeah, it's just for the direction. The negative sign is basically meaningless. Instead, I mean, it is just a definition. Negative sign here is not actually a negative sign, it's definition. So it's not arithmetically negative. It is just the definition of Lenz's law. This is basically what Lenz's law. Because Lenz's law says that the current is always going to oppose
Whatever the
Yeah.
thing is doing.
right.
Okay.
And the direction of the current is always going to be in a direction so that it opposes the change in flux.
So why is it negative here? Because
Wait a minute.
you said the negative is
Yeah, here it's negative here because when this triangle changes here, there's going to be a change in flux, right? So let's assume that the flux is increasing. By assumption, let's assume that the flux is increasing. It's changing because here you have flux, and here you have different flux, right? No flux, so it's actually decreasing. Let's just do it. Okay, let's do it that it's decreasing. Let's assume that it's decreasing. It's changing, right? In this case, when it's changing like this, the current that's going to be generated is going to be generated in a direction so that the flux, so that it creates its own magnetic field going through the loop in that way, so that it tries to oppose the change.
it's decreasing, so it's going to gain flux.
It's going to gain flux from the current. It's not actually going to gain flux. It's still going to decrease, but
yeah.
the current is going to try to make it gain flux. It's going to fight so that it makes it gain flux.
The current goes in the way that is losing flux.
That is, that is making flux. So let's see.
Whatever the flux is doing, the current is going to go opposite to that.
The magnetic field that is generated by the current is going to be opposite to that, so
yeah.
that the current, so the direction of the current you can figure out from by knowing the direction.
Is that why it's negative?
That's why just by definition, that's why it's negative, because it opposes the translated into a negative sign. That's just the entire reason for the negative sign. It's meaningless in arithmetics. It's meaningless if you don't have numbers to make the negative sign. So you really don't have to put it Imax, the magnitude of Imax. So if you want to get rid of this and not think about it, you can just put magnitude of Imax equal to magnitude.
Because in reality, it's like the current is going up, so let's assume this is a positive current, right? Or the positive B field. And if it's losing the current, we're finding, is that the current right there or the current of opposite B field?
This is the current of this. This has no current originally. Originally, this group has no current. When it moves, there is a current generated. That's the current we're talking about. So Imax, when is Imax going to be? When is it? At what time does Imax? Is the current maximum?
Or when it's back?
How is Imax? So, right, what is the EMF equal to? So Imax equals EMF over R, right? What is the EMF equal to? EMF generated by Faraday's law.
Changing flux over time.
Changing flux over time.
Negative changing flux over time.
Yeah, forget about changing flux and changing time, right?
Well, I don't know, there was a checkpoint question that was like, if flux is increasing, then EMF is decreasing, and it was specific to that concept.
Flux is increasing, and EMF is decreasing.
It says
EMF
up,
from
it's like
where?
the changing flux.
EMF is where? EMF is what?
Don't make us dumb.
No, that EMF. No, I'm not trying to make you look dumb, but
This would generate. So you're supposed to find output flux. Right. So here, the flux is increasing, so you have negative EMF, and then as it passes through, the flux is decreasing, so you have a positive EMF. Okay.
go with it. Positive means counterclockwise. That's
Well, look after that.
And
Dumb.
you have to find the flux, you have to.
It's just direction. Just in the definition, opposes. That's why they add that.
Mm-hmm.
To find the flux, you have to find B also in the
Okay, define it. You have to figure out which time, where, at what time is I maximum.
Isn't it maximum at half of this time?
I max. When EMF is max. When is EMF max? When d phi over dt is max. When is d phi dt max?
It's max. I don't know how you know
When is the flux, the changing flux, not flux. When is the changing flux here going to be max?
when you complete the whole thing, or
No, at what instant?
I don't know.
That's flux.
Half of time.
So, okay. So,
I would say when the time that is given, the time it completes a full circle when you divide it by 2, that would be. No? That's when there's no current passing through it.
that's when there's
No flux.
You mean when it's perpendicular to the, so when there's no flux here.
It's right now when it goes like
Yeah,
this
right,
before.
yeah. Oh,
So that's a quarter.
You said complete rotation. Yeah, quarter rotation. Quarter rotation, that's when it's
That's
time max.
Mhm.
Yeah. That's going to be
Quarter
max,
or
okay.
3/4.
Quarter or 3/4. Yeah.
I don't know that.
order. So pi over 4, 3. No, pi over 2.
So you have to do both of them?
Same magnitude, but different direction. They're asking about magnitude.
I got new notebooks today. I need new pens. Let's see. Keep track of things. And I got a me notebook.
Here it is, 25 minutes left, so
This is my me notebook.
get stuff done.
I am. Let's see how I wrote 2015.
Get stuff done.
It's neat. You're not impressed.
What?
You're not impressed.
You know how many things there are, and you know those things.
How was your spring break?
I slept. Slept and drank. Yes.
Oh,
I
What,
don't
you
remember.
drink water?
Yes,
Yes,
water.
lots of water.
Lots
Okay.
of water.
Okay.
That was a good time. All that water. It was like a water park.
I ate pineapples too.
Oh yes.
I ate pineapple as well.
It was good pineapple.
When I
we
was
don't have
soaked
a
in
current.
something.
Oh, we don't have a current. That's what we're gonna find.
Yeah.
I thought that's how you find current. Because in this, to find B, you have to be given a current.
That particular instance.
You have to find this. You have to find a flux, but then to find a flux, you have to find B. To find B, you have to know I.
Yeah.
Which you're trying to find. Or you have to find another I.
You shouldn't put it delta here because it's the original definition is d phi dt, right? When it's changing at a constant rate, you can put it delta phi or delta t. Like in today's example, not today's example.
So we just need flux.
Yeah, in today's example, it's d phi dt, d phi dt. D. Yeah, is it
It's
isn't
change.
EMF? Yeah, change, instantaneous
This is the
change.
same as D.
No, it's not.
It's
It's not.
the change is
Graph of phi versus t. D phi dt here is equal to delta phi over delta t. Delta phi over delta t here basically has no definition, unless you're gonna approximate it with something and that's not the specific. But I mean, so because you can't take 2 points, point here and expect that to be same as d phi dt, because if it was linear, if it was changing linearly, then yes. In this case, in the case of a rotating triangle, it's changing as a sine wave. So phi t is changing in the case of sine wave. And that's actually why d phi dt. So
it's a
cosine wave, right? It's a derivative. So
Yeah.
sine wave, derivative of sine wave is cosine wave, right? So that's going to be. When the flux is 0, change in flux is maximum. Or minimum. I think I did it differently. It should be negative cosine. This is negative the derivative. But yeah.
okay.
Because then it's cosine. No, that's right.
No, that's right.
That's right.
Half-
That's right. But yeah, it's
Now
maximum
it's
minimum.
circle minus.
It's gonna be maximum minimum. Whatever. The point is, it's going to be maximum minimum when this is 0. These are going to be maximum minimum when these are 0.
Report.
Here. These are 0. Sorry, here. 0. 0. Max. The max of one is the 0 of the other, and the 0 of one is the max of the other. Max or min, of course. When I say max, I mean magnitude max. Max or min means in direction, because this is with direction.
Okay.
What's the difference between Lenz's law and Faraday's law?
Lenz's law just tells you stuff about the sign.
But what is Faraday's law?
No, Faraday's law. Lenz's law states that the direction of the EMF generated is going to be so that it opposes the change of flux. That's not so.
What does Faraday's law say?
Faraday's law says that when the change in flux through a loop or a wire or something generates a EMF, doesn't tell you anything about direction. That Lenz can't.
Oh, we
Isn't that why the
the-
negative sign's there? For direction?
From Lenz's law.
But it's in Faraday's.
It's a Faraday's law.
Okay. Sounds good.
Is it 0 to 2 pi? Or 0 to
It's explained from
the order?
Sorry.
I'm sorry, B is given, we don't have to find B.
Okay.
Is it 0 to 2, 5?
Find it. Okay, so you need to find phi. Why do you have a B here?
No, the B is just to say
Subscript?
it's
Okay.
Is it 0 to 2 5s for interval? Or is it to pi over 2? 0 to pi over 2. That's when you find. No, 0 to 2 pi's. Because he does a whole thing, right? Right?
Hold on. I wasn't saw what you're saying. So.
You weren't listening.
Yeah, I was trying to figure out if something seems wrong. D dot what?
dA. And dA is 1/2 of HB.
Over R. So the flux through, no, this is not. So the flux through the surface of the loop is going to be, yeah, the integral.
I don't get this. I don't get the integral part. 0 to 2 pi and then what's dA? The area of the triangle.
You find an equation for the flux with time, and then you find the derivative of that equation and maximize it that way. But there's an easier way to do it.
You already have B.
Yeah, no, B, but what I'm trying to say is that, so the integral of B dot dA is going to be 0, because B is going that way, and at that instant, B is going that way, and A is that way, so, because no lines are going through the triangle at that instant.
Which one? What instant?
When the current is maximum.
Yeah. Are we finding the flux when the current is maximum?
We're finding the current when the current is maximum, or when the change in flux is maximum.
Does that have to do
When the
with
flux is 0. When the flux is 0, the change in flux is maximum, which means that the current is maximum. But this won't help us. It doesn't feel like it will help us. But if you want to find it through d phi over dt, you need to have an equation for phi with respect to a function phi as a function of t. Phi as a function of t. If you derive that, it can.
The integral of b dA, the integral of b dot dA, the derivative of the integral of b dot dA should be just b times a, cosine of w.
Here you're integrating respect to a, here you're integrating respect to t.
So
yeah, so you have to, if you want to do that, you have to turn dA into dt. So how does the area change with respect to time? The area changes with respect to time. There's an easier way to do this.
I think it's
complicate that.
It's the integral changes to a very simple b times area cosine of something. And that's what I don't know. I think it's cosine of
Cosine of omega t.
cosine
Frequency.
of w times
Cosine theta. Oh, right, you're right. Cosine theta. Cosine omega t w. So let's take a side view change or something, I guess.
Nope, opposite. Shift opposite. Like flip.
So let's just go into the page. I'm trying to take a side view so we can see the angle. Like looking at it from the bottom. So if we're looking at that from the bottom.
It's a straight line.
Yeah, here it's going to be a straight line. So let's assume at a different instant while it's rotating, because it's rotating like this, right? If you're looking at it from the bottom.
Yeah.
Right?
Yeah.
instead of looking at it like this, it's going to be looking like this. So it's going to look something like this, and a pointy thing into the board. So that thing goes like this or something.
You have it upside down.
What do you mean upside down?
Because it's rectangular while rotating.
Yeah, oh no, I mean, okay, I'll just draw it this way then.
Triangle, sorry.
I'll just try to draw it this way then. I mean that the other, the edge, the pointy edge triangle is going inside the board. I'm trying to draw that, why it wasn't successful at it. I'll just put this here or something. So, at this instant of time, you have this theta here, right?
Yeah.
Which is equal to omega t, because omega is theta over
It's omega t?
Isn't it? Isn't theta omega t? Because,
Yeah. Isn't it length? Or it's
length?
I don't know
What
what
is
the
length?
formula is. I don't know.
What is length?
I don't know. Okay.
Okay, we'll deal with this. Okay, I was trying to do that the area of a triangle equals to 1 over 2 base times the height, right? And they're assuming that this is the height is going inside the board, and this is your base here, right?
Mm-hmm.
So, at this instant, the triangle is gonna have a projection somewhere like this, going into the board. So the height is going to stay the same, the base is going to be decreased, so the base is going to be cosine, b cosine theta, that's a new base, so it's going to be a cosine theta. So a cosine theta, that's changing in angle, so that's going to be a cosine or sine?
Cosine.
Cosine. Omega t.
Omega t.
Omega t, yeah.
Okay.
Omega t is this is like velocity with distance over time, right? Omega is your velocity, but angular velocity. Right? Velocities.
And it would be just be a cosine WT over R.
So it's going to be A is
Area.
the area, yeah, and so flux is
Did you curse?
it's a flux.
Nice cover.
What?
Nice cover.
Why would I curse?
Flux. I lost my train of thought.
Sorry.
We're trying to find so B, yeah, flux is equal to B dot dA at any instant. The area is going to be a function of time, so that's going to be integration of B dA. Are we integrating cosine omega to there?
No.
Why not?
It's B that, the angle of B that dA that gives you B times area times cosine of the angle. Right? So if you integrate it, it will give you B.
No,
No?
because cosine is maximum at 1, which means cosine is a function of flux in this case. It is maximum at 0, so that's why cosine is a something. If cosine describes something, it has to be maximum at 1 and minimum at pi over 2, right? So it has to be maximum here. And the thing that's maximum here, right now, in this case, is flux. So that flux is a function of cosine. That means change in flux is a sign. But you can still use this fact. I'll think about a better way to do this because this is all over the place. But your answer for the moment should be BA cosine omega t at and that cosine go to 1, so BA. BA should be your answer. BA. Yeah, it should be. That's not flux. No, it shouldn't be.
I know.
Yeah.
So it should be an angle.
No, there shouldn't be an angle because
If
yeah, it should be BA. Should be BA.
oh,
Try BA. Try BA. If I'm wrong, I'll think about it. If not, then I'll think about it later because I can't think.
I don't know how to do this. How to start?
What's this?
Easy question. I'm thinking.
have you impressed it?
What's
Never wire.
You never impressed?
No, it's not your class.
Oh.
Oh, I'm not any.
What's the loop?
Flux to the loop.
Flux is integral b dot dA. You need to actually integrate this thing.
Yeah.
Actually, integration. Oh my god, no way. This is actually physics too.
No, that's easy. Okay, so b dot dA. The dA is equal to. So b dot dA. So I just do integration from 0 to 20.
So go from here to here.
Oh, from there.
And the area.
So 0. So it's distance though. So it'll be 52 to 100.
I just
I think it's a cosine.
You
Oh,
see,
W.
in the function, yes, you're right. There is a sine or cosine depending on. So if in phi, phi is a cosine function. Phi is changing as a function of cosine. That means the change in phi over d phi over dt is a sine function. There's an omega. Omega b times a. Omega ba. Yeah. Omega ba. Omega ba. This time I'm 90% sure. I was 80%.
Times omega.
ba times omega. B no. So
Over, and then this whole thing over R. That should be I max, but that's just
that's right. That's right. Yeah. Phi is ba cosine omega t, right?
yeah.
Phi over dt is equal to d over dt of this quantity, which is equal to ba omega sine omega t. I don't care about sines, so I'm just going to put this magnitude. I really don't care about sines right now because omega has another magnitude. This quantity is maximized at omega t equals to pi over 2. That means this entire quantity is 1. That means ba omega. That should be the maximum flux.
And the sign.
The maximum change in flux, sorry. Yeah. The maximum change in flux. So maximum d phi over dt is ba omega. That's your EMF basically. Because that's what we're looking for here. But yeah, this is a function of cosine, like you said. And I for some reason, I thought we were maximizing this. But we're maximizing this change in flux.
So what are we maximizing?
We're maximizing the change. Yeah, we're maximizing the current by maximizing the EMF, by maximizing the phi over dt.
Okay, so I have this. I have this.
Which goes from, what's that, here to here? You're integrating b. You're only integrating b with respect to u. No. So, yeah, b did, right?
Mhm.
But you have to but this is wrong because limits of integration. You're integrating length area.
Right, I'm
So
aware. So
you have to change the d to something that
do I
makes sense.
DLW? DLW?
Yeah.
Okay. I just wasn't sure. R is L, right? No. R is L.
Isn't that resistance? Not resistant.
How is it?
R.
R?
No, this R. Is equal to D plus L, right? Or just D.
D.
So it's equal to that. So it's equal to that. So equal to D. So that really. Does that look right? You think? Elevated from 0.52 to 0. I don't like you not.
What?
I don't like you not. If this was right. Hey, it was. Wow, that's actually surprising.
We can do this next time?
Is it right at 4:15?
No, yeah, it's not 4:15 right now, but I really can't think right now, so I'm
Oh,
really
no,
sorry.
no. I mean, is.
No, it's not it's at 4:30.
Okay.
Is it okay to continue next time? If you have any questions about the next one, if you don't have time, just email it to me and I'll try to respond. Or if I see you around, you're always sitting in MSV, right? I'll, if you want, I see you around sitting in MSV. I smoke a lot, so I'm in the courtyard every 5 minutes.
In the color room?
Courtyard. I'm the courtyard. So where you're sitting, the lounge, there's a courtyard right outside it. I'll go down every 5 minutes to smoke, so I see you there.
Oh, yeah. I don't go there.
Well, I occasionally, not every day, you know, but I mean occasionally. So if you do want anything, I can help you with it. Andrew, I see it always, so